All right, you're in Exploiting Lawful Intercept to Wiretap the Internet with Tom Cross. Tom is the X-Force Manager, X-Force Research Manager, sorry about that, at IBM. Tom?
Thank you. And thanks everyone for coming to hear my talk this morning. Can everyone hear me okay?
A little low.
Little low? Let me move this up. How's that? Better? Better. Okay. So, where do I start? All right. So I'm here to talk about lawful intercept systems in the internet and security issues with them. So a lawful intercept is a wiretap. It's a lawfully authorized wiretap. And there's been this debate that's been going on for I would say as much as 30 years now about how the telecommunications infrastructure of the future will work regarding the ability for law enforcement to perform surveillance of suspected criminals. And the debate is sort of defined by this belief that this sort of surveillance is either going to be easy or you're either going to have end-to-end encryption and there's really not going to be a way to do any surveillance, or we're actually going to be building infrastructure into the internet that enables surveillance. And so if we're going to, and so there's been all these different sort of salvos in this debate. One of the first was the Clipper chip, and you heard about it from Moxie earlier if you were in his talk. He kind of teed up a couple of the topics that I'm going to discuss. So the Clipper chip was an encryption system that had a backdoor, so the government, if lawfully authorized, could listen to your communications. And one of the things that happened to the Clipper chip is, in fact, the crypto system was proven to be weak. And so, as a consequence, someone might be able to access the data without authorization. There's, at about the same time, this is from the early 1990s, in the United States, this law called the Communications Assistance for what? Okay, we're going to switch. Okay, can you hear me now? It sounds louder. All right, so there was this, in the United States, there was this Communications Assistance for Law Enforcement Act, and what it said is that if you were building telecommunications infrastructure, you had to create facilities that allowed law enforcement to access the content on your network. The impetus for this was that at that time, telecommunication systems were getting more and more complicated, and so the idea of simply wiretapping by using alligator clips was becoming outmoded, and they knew that that was going to continue to happen in the future. So they wanted to sort of require the phone companies to build in a way for them to do this. CALIA has parallels in other places in the world, and that's going to be important as I go through this discussion. In 2005, the FCC ruled that CALIA applies to broadband internet providers. So originally, when CALIA was passed, there was this compromise that said that internet services were not covered. But over time, they, I don't know, it's somewhat of a reversal. It's not a complete reversal, but they decided that broadband internet providers were telecommunications companies, and so they had to comply with CALIA. So that brings us, so originally a lot of the CALIA equipment had to do with wiretapping telephones, but if we have to comply with CALIA in the internet, then we need to have internet wiretapping infrastructure, and that's how we get to this discussion. The IETF published an RFC, which was RFC 2804. I think it was in the year 2000. About the concept of internet wiretapping infrastructure and whether IETF standards should take internet wiretapping into account. And their argument was that they should not, and there's a bunch of different reasons for that. But one of the arguments relates to that thing that I said before, that sort of bifurcation in this debate, where you think that wiretapping is either going to be easy or it's going to be impossible. You're either going to have end-to-end encryption where you can't do any wiretapping, or you're not going to have you're not going to have enough encryption, and so there's going to be a place where it's easy to hook up and do wiretapping, and so you don't need infrastructure to support that. The other thing that the IETF said is that the internet should be free from security loopholes, and there's a concern that if they build wiretapping capabilities into the internet, that they could represent a security weakness that could be exploited by somebody. So in having said all of this, the IETF also said that if you're going to do this, if you're going to build an internet wiretapping infrastructure, that you should publish the details of your architecture so that people can peer review it from a security perspective. And this makes a lot of sense if you consider the fact that all of the protocols that underlie the internet are all public documents. They're all IETF RFCs that you can go download and read. Anyone can understand how the internet works. And so if there was some secret mechanism that was being used for wiretapping in the internet that wasn't also subject to being published in this way, that would sort of be antithetical to the overall overarching philosophy upon which the internet was built. So in keeping with this policy, Cisco published an RFC 3924, explaining their architecture for lawful intercept and IP networks. Cisco had to create this architecture because they have customers who are forced to comply with CALIA and other similar laws in other countries, and so they have to introduce wiretapping infrastructure into their internet systems. And so Cisco came up with an approach, and they published it in this RFC. And basically, so their approach is loosely based on an architecture which was defined by the European Telecommunications Standards Institute for wiretapping. It's an SNMP v3 based interface that allows you to, there's a MIB that you can access that allows you to provision a wiretap. So one of the reasons that the IETF said that you should publish these architectures is so that we can peer review them for security reasons. And so that's what essentially I'm going to do in this talk. I'm going to look at this architecture and consider some of its security properties. And I think that there are properties of this architecture that are not as secure as I think they should be. And so I have some input about how I would design this if you ask me. So the first thing I'm going to do is I'm going to explain how this architecture works. So here's the overall architectural diagram, which I pasted right in from the RFC. The thing over on the right that says LEA, that is the law enforcement agency. So some of these blocks in this diagram are actual network devices, and some of these blocks are groups of people. The LEA is a group of people. They decide that they're going to perform a wiretap. They go out and they get lawful authorization to do it, and they go to this thing called the LI administration function. That LI administration function is also a group of people. They usually work for the service provider, or the service provider can outsource this to a third party. These are a bunch of sort of screenshots of advertising material for different companies that offer this lawful intercept outsourcing service. And so what these guys will do is they'll take the authorization, they have lawyers there, they'll take the authorization from the law enforcement agency, they'll validate that it is in fact lawful, and then they'll go and they'll provision the wiretap that was specified in the warrant or whatever authorization these guys had. They provision the wiretap using this thing called a mediation device. And the mediation device is in the center of this diagram, and as you can see, it's sort of the architectural core of this lawful intercept system. The mediation device goes out and sends messages such as this SNMP v3 message to devices that can actually do the wiretapping, and then it collects the results of that wiretap and packages it and provides it to the law enforcement agency. There are a bunch of different companies that make mediation devices that interoperate with Cisco routers and support the Cisco architecture for lawful intercept. And this picture is just it's from the marketing material from Verint, which is one of the companies that makes these mediation devices. So there are two IAPs in this diagram. An IAP is an intercept access point. There's two kinds of them, and this represents sort of a historical concept in most Western legal systems that there's a difference between collecting content and collecting addressing information. The most ancient kind of telecommunications is a letter. And a letter has an envelope with an address on the outside. And so a postman could easily see who you're mailing letters to. But in order to read the content, he'd have to go to the trouble of steaming the envelope open in order to read it. And so most legal systems over a long period of time have developed this idea that in order for the police to see addressing information, who you're calling, who you're emailing, there's a sort of a light amount of lawful authorization that they need. They don't have to have a high level of suspicion. They don't have to have a lot of documentation. But there is some process that they have to go through, but it's not as heavyweight as the process that they have to go through if they actually want to see the content. The content is more carefully protected. And so that actually ends up being reflected in this technical architecture. There are two kinds of intercept access points. The IRI intercept access point can only collect, it's a specific device designed only to collect header information or routing information for cases where these guys only have the lawful authority to collect that kind of data. The content IAP it can collect the entire content of someone's communication. All Cisco routers who support this interface are content IAPs. So I'm not going to talk about IRI IAPs anymore in this talk. So there's this interception request labeled D here that is the SNMP v3 request that I talked about before that gets sent by the mediation device to the router and tells the router to go ahead and provision a wiretap. The interception, so this is sort of part of the MIB for the interception request. The MIB is published in an internet draft. It's not an RFC, but you can find it fairly easily by Googling around. There's a bunch of different things that the person provisioning the wiretap can specify. They can select the source and destination addresses and source and destination ports for the traffic that they want to collect in their wiretap. And they can also specify where they want that data to go once it's been collected. They can specify the address and port number of the destination host, what transport, and I'll talk in more detail about that, and whether or not notification is enabled. So there's a lot of flexibility in this architecture. So let's take a step back from this whole thing and ask ourselves, like, what are the different security issues you would need to think about if you were building this wiretapping system? The first thing you would want to do is prevent the subject from discovering the surveillance. In the RFC that Cisco published, they described the fact that they don't add additional hops to a trace route, for example, to make it obvious that there's a new device in the network. They built it into the router that's already there. Some people have asked, whether enabling this interface would have a performance impact in the router, and I wasn't able to study that, but it's an interesting question. If you could observe that the network performance is slow today, that might mean that they're wiretapping, but it could mean something else too. So I don't know how reliable that would be as a method of detecting the presence of this. Another thing that you need to think about if you're designing a wiretapping system is preventing the subject from manipulating the surveillance. So there's a really interesting paper called The Eavesdropper's Dilemma that Matt Blaze wrote and published, I think, a couple years ago that talks about this subject. If you suspect that you're being wiretapped, so let me explain it from the other perspective. If you're wiretapping somebody and if you they send a packet, for example, with a bad checksum, you can do one of two things with it. You can either throw it out because you think that the end host is also gonna throw it out, or you can include it with the content that you've collected because you think that the end host might actually interpret it. And so that gives the subject a couple of different options if they want to confuse you. If you're collecting packets with bad checksums, they can send a whole bunch of those in addition to the real messages that they're sending. And those additional messages that they're transmitting that aren't being received by the receiver might confuse the person performing the surveillance as to what's being discussed. On the other hand, if you decide you're going to throw out packets with a bad checksum,